researchers, regardless of what you're doing, have to have a healthy dose of curiosity. Otherwise, you're not a researcher. Simple. But with that, you also want to be a bit realistic. So once you've done your research, you always want to ask yourself, is it reasonable? Is it the right answer? So be a little bit skeptical, but don't start off that way. Anyways, that's what we're going to talk about in this video here. GERA Foundation presents this series called Navigating Research. This schematic perfectly demonstrates what I'm talking about as it relates to how we do science. And here, it's for accountants. So it gives you an idea that these are skills that can be applied all across any form of anything that's being done. Anytime where you have to do some kind of investigation, whether you're a police officer, an accountant, or an astronomer, you really want to be curious, but you do want to have a bit of skepticism. And that's all there is to it. So this thing perfectly demonstrates that. Here we're talking about enhanced analytical skills. Well, scientists have that in spades, right? We want to be curious and inquisitive. Of course we do. Otherwise, we're not doing research. We're just basically solving problems. And more importantly, in this thing, you can start seeing things like professional, developing professional judgment. And those words get thrown around a lot because in the field of accountancy, you get jobs where you're basically a financial accountant of some ilk, and you really want to be very careful with other people's money. And that's all there is to it. So, and the same should be true in astronomy. We really want to be careful that what we're publishing is reasonable, follows what we think is good scientific discourse. And so the words professional should fit into ours as well. Curiosity, I firmly believe we should go through the world with a form of childlike wonder. And I try to do that. I'm not always successful, but I try to do that. If there's one thing that you can do is look around you and remember what it was like as a child to see something for the first time, something interesting and different. So I firmly believe go through the world with a form of curiosity equivalent to childlike wonder. Well, curiosity killed the cat, but you can see here she's quite alive and well. Her predecessor, regrettably, did not fare so good. He got eaten by coyotes, so maybe curiosity got him killed, but so far she's alive. Anyways, be careful with curiosity. And why should you be a little skeptical? Well, the simple answer is when you get to the edge of that cliff where science ends and fantasy and your imagination begin, you don't know how deep the water is or how large that gap can be. And you may not make it. And bad things can happen to you, both to your career, to you personally, but that's just the way it is. So really, look before you leap. You got to be a little skeptical of the stuff you have. Don't be completely blind to your own science and think you've done a wonderful job and everybody's going to love what you did. Be a little skeptical. Look before you leap. In 1987, while at a conference in the Rocky Mountains, it was at Whistler, BC, I think, myself and a friend were climbing up into the mountains, up onto Mount, what was it called, Blackcomb. Anyways, and I found myself, he and I got separated, and I found myself at a cliff, literally like this, where actually the other side was slightly above my head, and I couldn't see the other side. I couldn't see what was on it, what it was. I could just see the gap. And the gap was probably maybe 6 feet across. Anyways, long story made very short, I simply decided I'm just going to leap up onto the other ledge, pull myself up, and carry on climbing. And I did this, but as I landed, I started sliding off because there was loose gravel on it. And I was literally down to my hands and my chin. And I was able to pull myself up, and that's why I'm here today still talking. But otherwise, I would have fallen through that cliff because it was down tens of meters. I can't remember the height. It was probably at least 50 feet. Anyways, so I literally leapt before I looked once. And I did this often sometimes in my career, both physically and research-wise too. And it makes mistakes. And mistakes can hurt you. Plain and simple. Could kill me as it almost did in that case. Luckily, I'm here. Anyways, yeah, look. Here's a great example of what I'm talking about. Now, this is a dynamic spectra. I've explained it in other videos. I won't do it here, but basically it's my spectra turned into contour maps. I stack all the epochs of observation up, and I can make contour maps. So the contours, the colors, are the strength of the masers versus velocity, and then each epoch gives me time. So you get here years. Here I've got about 10 years of data, and certainly I'm still observing this source, so I have into 2023, and I will continue observing it. Okay? And what we found in this thing and published was that there was a giant flare, an accretion event occurred right around here. Actually, on this blue line is where it started, and it reached its maximum here. And then died out, and gradually died out. And that's the result of gas and dust falling onto a massive star, causing a huge burst of energy, causing my masers to turn on and get very bright. No train smash. This was, once we knew what it was pretty clear what was going on, and that in itself was the exciting discovery that was made in 2015 and published thereabouts. Anyways, but for most people looking at this image, the more curious is these two wiggly lines at the bottom. And remember, this is velocity versus time, and these are contours. So my contrails, the result of the maser going across the sky, is rising and then falling, rising and falling very periodically. When it's rising, it's actually a Doppler shift away from you, and when it's falling, becoming more negative, it's Doppler shifting towards you. Okay? So that's very curious. But the question is, what the hell is it? And I remember when I first saw this, I had no clue. And then you start thinking, aliens. And I tell my students, hey, never use aliens as a go-to. Always have a list. Do your Sherlock Holmes. Have a list of possibilities, and then start stroking off what it isn't, and then whatever you're left with, however improbable, it has to be the answer. And it could be aliens. Now, in this case, the piece of information which demonstrated it wasn't aliens was I figured out that the time between these peaks is 365 days. And once you see 365, you know this is the result of the Earth going around the sun. So something must be causing this. And the answer is how we correct the velocity of the spectra, because we have to correct for the Earth motion when we do our observing. And we obviously have made a mistake for whatever this source is here. So these two masers here probably are not at the beam center. In fact, they're not at the beam center. They're from another source entirely, but because the beam of the Hart-Rail telescope is so large, they're in the beam, and so I detect them, but I'm not correcting them for the correct VLSR value. So here it's corrected, here it's uncorrected, and I'm injecting literally the sinusoid of the Earth going around the sun. That's all it is. That's it. So no, it's not aliens. But the point is, it's a perfect example of curiosity with a healthy pinch of skepticism. Because had I published and said these were aliens, and then someone comes along and says, no, Gordon, no. My career would have been over. So curiosity, but with a healthy pinch of skepticism, keeps you alive. Don't be a cynic. Because you're basically convincing yourself that whatever you're thinking about is wrong, and therefore you'll never put enough effort into seeing if it's in fact right. So don't be a cynic. That's the difference between cynicism and skepticism. One's got an element of negativity to it, and the other is just basically, it's just a form of doubt. Clearly, I'm not the only one that thinks of these kinds of things. I'm just doing this because we have students that may not give any thought to it. But out there in the metaverse, in the universe of Google or whatever search engine you use, you'll find a myriad of documents and theses, literally dissertations, on the topics of curiosity and skepticism. That's all there is to it. There's books on the damn topic. But the simple answer is, as they're saying here in the layout of this particular thing, is why does it matter? How do we cultivate a society in which we're curious? Okay, how do we apply the skepticism? How do we balance it? And then they get this practical, critical thinking and learning and so on and so forth. Anyways, but there's lots of people talking about this stuff. But the simple answer is you got to start by being curious. Got to start by being curious. Whatever you do, be curious. You know, take a look around. Like I said, act like a child sometimes. And more importantly, just enjoy it. Enjoy it. You know, life isn't about, you know, I'm a serious researcher, I got to be serious. To hell with that. Have fun with it. Enjoy it. You know, get out there and see the world and imagine things and just enjoy it. And then be cool. Find cool shit. Okay, find cool things. Let me say it like that. Too late. Anyways, yeah, so I'm not the only one, clearly, but I'm just telling you, look, be curious, and then be a little skeptical of what you find until you absolutely convince yourself you're right, and then publish. The GERA Foundation will produce more videos like this. Please like, share, or subscribe if you enjoyed this video.